In this video, we're going to see how we can consider the derivative of a function as a function itself, and we're going to talk about things like what should the domain of the derivative be. So, you see, if we have a function f, for each x where f is differentiable, we can define f prime of x, which is associated to this point x. So, we can view the derivative as a function, where f prime of x is just the limit as h approaches 0 of f of x plus h minus f of x over h, or the limit as y approaches x of f of y minus f of x over y minus x, whichever one you choose. Here x is the one that is fixed, as you see. It plays the role of the a in the previous video. Okay, so now we have a function, and we call this the derivative of f as a function. It's the function derivative of f. The domain of this function then is the set of all the points for which the derivative exists. So it's the set of points where my function is differentiable. And the domain of the derivative may be smaller than the domain of my original function, as we're going to see in the next example. So we want to find the derivative of the function square root of x. Okay? Here, f prime, first of all, is a two-sided limit. So we don't expect a derivative to exist for x less than or equal to 0. There's no way to really compute the limit because square root of x is not defined for negative values of x. So there's no way I can approach 0 from both the left and the right. So that's to begin with. Okay, now if x is positive, we have that f of x plus h minus f of x over h is the square root of x plus h minus the square root of x over h. Good. Now I'm going to multiply and divide by the conjugate, because what this will allow me is to have now that this is x plus h minus x over h times, well, the square root of x plus h plus square root of x. Good. But then now x plus h minus x, the x cancels, so we end up with just this expression. That also, remember, we left h divided by h, they cancel as well, so we're going to have just that this is 1 over the square root of x plus h plus the square root of x. And we have to take just the limit as x approaches 0 of this thing. Now, the square root function is continuous to any point in the domain. So for any x greater than or equal to 0, my function square root of x is continuous. So that's why I can just plug in 0 to compute the limit. And that shows me that the derivative of the square root function is given by 1 over 2 square root of x. And as we see here, the function f prime is only defined for x's that are greater than 0. So the domain is open at 0. And this is smaller than the domain of my function f, which was originally defined to include the point 0.